All right, guys, welcome to day one on our school dismissal. Lesson one will be today, will be on volume of cylinders. So if you have a notebook out, write down volume of cylinders, and we're going to talk about this idea of volume of cylinders and what a cylinder is. And I'm going to do my best to draw, and you could as well. Draw a cylinder. Think about, hey, let's talk about toilet paper. Everybody else is. What's that toilet paper roll? That's a cylinder, correct? So that's just a smaller cylinder. What other cylinders do you see in your life? Do you see Pringles cans? I think that's something that jumps out at me as a cylinder. There's so many different types. If you go into like Texas, different areas where they keep corn and different things in silos, those are huge storage containers that are also cylinders that they have to be concerned of the volume. Now, volume is what? So when we talk about volume, we talk about something that's kind of separate from what you learned last year. Let's just talk about this real quick. You learned about this thing. It's a circle. You learned a lot about circles your seventh grade year. And the line all the way across, looks like a little Pokemon ball now, right? All the way across is called the diameter, right? The diameter is from one side of the circle to the other, shows the whole distance across. Now, what if I cut that in half? We're going to be dealing with this a ton today. What's just this distance from the center to any part of the circle is called the radius, all right? And you remember that from last year as well. And what you need to realize last year that you learned about how to find the area. How much space can you fit inside this whole circle? How much space, the area, you found out a formula. And the formula for area or for a circle was area equals pi times radius to the second power, pi r squared. And that's important to understand. In today's formula, you're going to have to learn about volume. This is the huge deal today. We're going to learn about volume, and we're going to talk about how we get to this point of area equals pi times r squared, the area of one of these circles. So to illustrate this to start, I want to show you, let's go ahead and show you something. You ever had the game where they talk about maybe trying to find out how many jelly beans are in a jar? And they say, just go ahead and give me a guess. Give me a random guess. You ever had those instances? And did you just randomly guess, or did you actually try to think about it mathematically? Did you try to really study the jar? Maybe you could actually hold the jar. Maybe you could look at the jar. And if you could, there is a technique that you could use to try to help you. All right. So what you would do is you would take this jar and you would probably lift it up. This picture shows the top of the jar, but what I would do is probably lift it up and count how many jelly beans I can see on the bottom. But let's do it this way where we can see on the top. How many jelly beans would you be able to see on the top, fully see covering like the first floor of you're looking at? Think of it as a building, different floors in the building. And if you count it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, maybe about 40. If you kept counting, and we're going to, in essence of time, take this a little quicker, but what if there was like 45, maybe 40, maybe 50? And that was your top layer of your jar right here, right? Then what would you do? What would you think about doing? Would you think about counting how many other levels are there on or in this jar? How tall is this jar? How many other layers of this 45 jelly beans are there? Think about it as a building. How many floors are there to the building if you wanted to count it that way? And what would you do with those two numbers? Say this was 50 jelly beans. Let's just say that. And then let's say there was, let's say 30 floors. We counted 30 different levels here total. What would you do with those two numbers? Would you take it and would you go 50 times 30? Would you multiply those two numbers and get 1,500 and you can guess around that many jelly beans if you wanted to? This is a way to kind of solve these kinds of questions. And guess what you're figuring out? In a sense, you're figuring out the volume of this jar. How many jelly beans can you fit? So when we talk about volume, we're talking about how much, think about your water bottle. How much water could you fill into that water bottle? So the way you should do it initially in your mind, you should take, let me get a different color here. You should truly first try to find the area of the circle, of the base, of the bottom of the cylinder, find the area of that. And we just talked about what's the area of a circle right here. Then we should think about, okay, now that we have the area of the circle, now we know how much is here. should we try to figure out how, let me take my stylus here, how many floors are on here? Should we try to figure that out? And what would this be? You would try to figure out from here to here, what could we call that in a sense? Could we call that the height of the jar? Could we call that the height? I mean, this is a way that we can actually go about doing it, okay? So now looking at this, we can find a formula. We're going to take this part here of what the bottom of the circle is, the area, and we're going to take that and we're going to multiply it times the height. So let me move this out of here. You're going to write this in your notes. It's going to be pi r squared times height, and that's how you get the volume. And this is what we're using all day today, and we're going to practice that. Okay, so volume equals pi r squared times the height. We're figuring out the volume of the circle on the bottom of your cylinder, or the top, doesn't matter which one you figure out, and then you're going to multiply it by how tall or how much height your cylinder has. Okay, so let's go ahead and do some problems, because that's the best way to practice on this. You're just going to get some practice doing all these problems. Let me go ahead and erase all this and pull this up real quick. All right, so let's go ahead and look at this problem. Now we're going to go ahead and handle, actually on the top, I'm going to go ahead and you can put this in your notes again. Just go ahead and draw this out, draw the shape out and put this in your notes. Volume equals pi r squared times height. Okay, and let's take a look at what we have. And let's set this up in the formula. So your volume is going to equal, what is the pi? Or wait, excuse me, what is the r? You know if it's going to be pi. And sometimes on your quizzes later, you may just have to substitute 3.14. I'm going to show you right now on your SPEC calculator that you actually have a pi button that you should use. But when you look at your answer, like, make sure if it's a multiple choice that you look at the answers they have. If they use 3.14, you might have just slightly a different number in your 100th spot or your 1,000th spot or your 10th spot even. Okay, so just take a look at your answers. Now, r squared, where's my r? 6.5 squared. We're going to put that there separately. We're going to multiply those two together. And then what's my height? 16. And you're literally going to plug this into your calculator. So let me go ahead and open my calculator. This is an easy concept, guys. I don't want you struggling on this at all. So my calculator, I'm going to go ahead. I said there's a pi button. Pi times 6.5. And you guys know this button as well. Squares it, right? So we're good there. And then what was the last part? It was 16, okay? So let me go ahead and go times 16. And there's my answer. And again, if it wanted me to round it to the 10th, would I raise it? Would I raise this number up again when we talk about rounding to the 10th? When I'm looking here, is that 1 going to make this 7 turn to an 8? Nope. Now, if it said round to the 100th, interesting, that's the 100th spot. Then I would look at the thousands. If this is 5 or more, raise the score. 4 or less, let it rest. So if it was to the 100th, it said round to the 100th, you would have 2123.72. We're going over rounding a little bit because that's important. All right, let's keep going. Let's see. Next, I'm going to clear all this, and we're going to go to the next problem. All right, let's go through these pretty quick. All right, as I look at this one again, volume equals pi r squared times height. Do not forget that. Again, we're figuring out the pi r squared is the circle on the bottom of your cylinder, and this height is just the height from where you're going back here, okay? So don't forget those. Let me get that there. So now, when you handle this, you're going to look at the two different parts of this problem. Volume equals, we know pi is going to go in there. Now, r, this is where it gets a little interesting. Your r should be from here to here, correct? But what did they give you? Did they give you the radius? That's what the r stands for, or give the diameter. They gave you the whole thing. So we're just going to cut that and chop it in half. We're going to chop it in half. Half of 4, that's pretty easy. 2, and we're going to square it, and then we're going to times it by the height. Easy peasy, okay? So let's go ahead and put that in there. And really, I mean, we can do this almost in our head if it was left in it. So sometimes it might be left where the pi sign is left in the answer. But again, if we have our calculator, we're going to go ahead and handle this way, times 2 squared, which we already know is 4, times, what was it again? I keep forgetting. Was that 3? Okay, cool, 3. And Our answer is 37.6. Okay. Now you're thinking, okay, it could be 37.7. If it said round to the 10th, wouldn't we bump that up? 37.7. Okay. What if it said to round to the nearest whole number? These are your whole numbers. Would it go up to 38? It would, because of that right there. So think about how you're rounding. All right. Best you can with that. Sometimes that skill just seems to miss when I teach second eighth graders. And I'm like, oh, what happened? All right, let's keep going. All right, now, yay, we have a word problem. I'm sure you guys are excited about that. So, New Oat cereal is packaged in a cardboard cylinder. The packaging is 10 inches tall with a diameter of 3 inches. What is the volume of the New Oat cereal package? Okay. So we're looking at a cylinder. Always draw the problem. Every word problem, you should just draw it out. I really need you to see it. You got to see it in your mind. We're so visual when we learn these kind of concepts. What's my height going to be? Well, it looks like it's 10 inches tall. Okay. And then my diameter, the whole thing is going to be 3. So what's my formula? Volume equals pi times r squared. Well, what's r going to be? Well, we have 3. What's half of 3? If you had to cut $3 in half, you're going to give your friends $1.50 each, 1.5. Does that work? And then times 10. Go ahead and do your calculator. And let's round to the 10th on this one. Let's see how we do, okay? So we're going to clear all this. We're going to go pi times 1.5 squared times 10. Round to the 10th. I look at the 10th. Am I going to bump that 6 up to a 7 or just let it rest? Well, I have to look at this right there. That 8 tells me that the 6 goes up to a 7. So it becomes 70.7. Okay, if we round it to the 10th. Alrighty. All right, let's look at this last one here. Mr. McCady has an old cylindrical grain silo on his farm that stands 25 feet high with a diameter of 10 feet. Mr. McCady is planning to tear down this old silo and replace it with a new and bigger one. The new cylindrical silo will stand 30 feet high and have a diameter of 15 feet. What is the volume of the old silo? What is the volume of the new silo? How much greater is the volume of the new silo than the old silo? So the question's not too tough, but you have to break it down in, okay, let's do this one over here. We have a silo over here, and we got what? It's going to be 25 feet high with a diameter of 10. So can I just right away say it's a radius of 5 and not even mess with the 10? Okay, so my volume is going to be pi times radius squared times 25. All right, and then my new silo is going to be, draw it out. I know I'm a little messy drawing right now, but it's okay. It's going to be 30 feet high and a diameter of 15. What's half of 15? 7.5 or 750. So let's plug that in. Volume equals pi times 750 squared times 30. Okay. And let's go ahead and deal with these two different problems right now with the calculator. Calculator's your best friend. Okay, and look what I did here. With my calculator, I did it pretty quick. This is the old silo. Okay. This is the new silo. Plugged in the formulas. And then this is the new silo minus the old silo, which would give you how much space. So it's probably smart this guy's getting a new silo. He's going to have a lot of grain he gets to add into that. The volume of grain gets to be put in there. So this is going to be helpful. Guys, you're going to go ahead and do the quizzes now that I have assigned with you. I would love for 100% accuracy. If you want to retake it to get to that point, that would be perfect. All right, guys, memorize the formula. You have to memorize it for the SBAC. Do the best you can. All right, and then look for day 2 tomorrow morning at 8 a.m. All right, guys, best of luck. Hit me up on Remind, or you can email me, or you can send me a comment in Google Classroom. All right, guys, take care. Be safe, be healthy.